So in our last class, we talked about what is a stack. We talked about the stack data structure, the operations of a stack, that is push, pop. Okay, we have seen how we can actually apply stack using singly linked list. How we can apply stack using uh, array. And then we have seen how this push, pop, top, and other functions work. We have also seen that in the stack data structures, okay, if I want to write my own push, pop, or top function, how the code should be, what small changes that I need to make, and so on. Then we have talked about that what are the time complexity of different stack operations. We have seen that in the stack we have this applications where using stack actually gives us a better result. And also we have actually seen one application that given equation, what we did step by step, just by using a stack, we evaluated expression. That takes a very complicated programming if we don't use stack. So this is the basic idea that we have covered in the last class. Today we will talk about notations. Okay, so we'll talk about three types of notation: prefix, infix, and postfix. We will see how we can convert from one type of notation to another type of notation, and what is the advantage of this notation. So first of all, what is a notation? Notation is the way to write arithmetic expression. Notation is the way to write arithmetic expression. There are three types of notation: infix, prefix, and postfix. So let me show you an example. What does infix means? So whenever you actually write an equation, okay, whenever you write an equation, that we use either postfix, infix, or prefix. So normally in human mathematics, okay, what we do, we always actually use infix. So what does infix means? Infix means very simple, that whenever you're writing an expression, the operator, that is the plus sign, the minus sign, will be in between the two operands. That means if you want to add two numbers, let's assume 5 and 2, you will write 5 plus 2. If you want to add two numbers, if you want to multiply two numbers, okay, let's assume 5 into 2, you will write 5 into 2. We are very much familiar with this one. Okay, we have so far I think you have only seen this type of equations in your mathematics, but this type of mathematics has some issues, problems. So here, as you can see, this type of notation that we call infix, it is easy for us humans to read, write, and speak in infix notation, but at the same time it does not go well with the computing devices. So whenever we are using the computing devices, okay, it doesn't actually go well. Now why we are actually learning this, I will go back to that a little bit later slides. So in short, infix notation that we use, okay, you can add whenever you're adding or using any type of operation. What we do, we write the operator in between the operand. So a plus b, we write a plus b. Okay, this is easy for us human, okay, but at the same time it does not go well with the computing devices. Now an algorithm to process infix notation could be difficult, costly in terms of time and in space consumption. So we have actually seen, discussed the example in the last class, that how the processing of infix notation, that means a normal expression, becomes actually difficult without. Now here's an example of it. So if you want to add, you see this is the equation 2 plus 3 into 5. So here, if you want to make sure that out of these two operands, okay, normally we know if there are any rules. Okay, so what is the general rule? The general rule is that multiplication should go first. But if you want to, for some reason, want to make sure that plus sign get executed first, you have to add a bracket, because bracket has higher priorities. Okay, if you want to and this is actually not needed for human language, because we know that multiplication always goes first, gets higher priority than plus. So the first one is actually needed. Okay, yes, Jubair. Okay, I think he did a mistake. So infix notation,
Yes,
we
sir.
actually needs parenthesis. Okay, so normally we use the formula, like there's a formula like the division will be the highest priority, sorry, the brackets will be the highest priority, then there will be division, there will be multiplication, there will be sum and subtraction. But apart from that, okay, if you want to make change the order, okay, we have to use parenthesis. Now what's the problem here is this: if we actually try to use a different notation, okay, what if there is a better approach where we don't have to worry about that? So one example is prefix notation. So what is a prefix notation? Is basically means that instead of writing the plus sign in between the two, that is a plus b, okay, what we will do, we'll write the plus sign before ab. So basically plus ab. So whenever in prefix notation, if you want to add two numbers, you will write plus ab. In prefix notation, if you want to add two numbers, you will write plus AB. So basically the operator will be prefixed before the operands. Okay. And in infix notation, what do? We write A plus B. So this prefix notation is known as a Polish notation, and this is actually a very, very important topic. Okay, but at the same time very easy. Okay, you can actually easily understand that how this works. Okay, now there is another one that is okay. So first let's finish this one. So what is the advantage of this prefix notation? That instead of writing in between the operands, that is a 2 3 5, we should write before the operand. So what is the advantage? The advantage is, first of all, no parenthesis needed. This is number one. Number two, if an equation is in this form, we can actually evaluate this using stack. So in the last class, the example that we have seen is actually a postfix notation. So as you can clearly understand, post means that it will be AB plus. Okay, so what we have seen so far, that we have three types of notation. Okay, one is the infix, okay, that we actually have been using so far. Okay, so infix is basically A plus B. Another one is prefix, that is we write plus AB. Another one is postfix, that means we will write AB plus. Now why we are learning all these two new ways to write equation? Because infix is easier for us as a human to read, write, and operate, but prefix and postfix are easier for computers. And as a programmer, we should know how to actually better communicate with the programmer. It makes our life much, much more easier. And there is official, there's a bookish term or official term for it. This is called Polish notation. So prefix is called Polish notation, and postfix is called reversed Polish notation. Okay, so that's it. Okay, so that is the basic definition part. Now we will go to we'll see that how it actually works. So this is another example that of postfix, that you see all the signs 2 3 5 are written, then into and plus. And in the last class we have actually used a postfix expression equation, and from that equation we have actually just used a stack to calculate equation. And you have seen that how easy it was. We only needed to remember 3 rules, and rest of it was actually very easy. The stack was doing all of the tasks. It was far, far better than actually doing other way. Okay, so same goes for prefix as well. Now one thing that we have to worry about before I jump into the mathematical details. So FPE, the term FP basically very simple, fully parenthesized expression, that given you have a expression, whether the expression is fully parenthesized, that means if all the brackets are properly given. So you see here, you have 3 options and you have to find out which one is actually accurate. So we can clearly see this one is not accurate because there's a bracket missing. Okay, now the question is, this one, we know this one is wrong because the bracket is missing, the one I have just drawn using red. But between these two, is this one correct or this one correct? Now this actually becomes a little bit confusing, because we understand this is actually okay. Okay, but what about this? Should we have a bracket before C? Okay, or should we not? So this is actually okay. So first of all, Najmul, you know, I can see it that whenever you draw on the screen, this is your strike, and I'm actually kicking you out of the class. I don't need students like you. Just give me 1 minute. Let me just find him, and I'll kick him out of the class. Okay, so I'm back here. Let me resume it. I have told you before that taking data structure properly is actually a big challenge, because this is a very important course in your lifetime. You can learn these things over the internet, okay, but not everyone actually learns from the internet. That is a problem. And if the distractions like this actually make it more difficult to take the class, the other courses I'm taking, those are actually not that much challenging. Operating system, graphics, because there are a lot of theoretical parts to that. People can just memorize stuff, and there will be no actually, there will be not that much questions they have to face in their after graduation. Okay, I have actually graduated and faced many vivas, and I know that no people actually ask that much question about what did you learn in your operating system course, okay, or in your graphics course or your assembly course. Okay, so some of the courses people actually don't care about, but if you went a data structure, this is actually a course that everyone cares. And disturb distraction in this class is actually very much problematic. Okay, so anyway, let's, without talking any further, let's go back to the class. So as I was saying that, so we have to find out that which one is actually fully parenthesized. Okay, so whether this is this one or this one. So normally we know that this one actually looks like a perfect one, because there should not be any bracket before C, but sometimes you can also use this one. Okay, so between these two, sometimes you might get confused. Okay, but both are actually correct in a sense that you are actually, this two doesn't have any difference. If you calculate both of this expression, okay, there will be actually no change. Okay, but this one is actually the accurate one, because this is actually redundancy, and in programming we actually try to avoid redundancy, right? Now, so why we're talking about this FPE fully, you see that you will see that very in this slide. So normally whenever you actually write an expression, okay, so we have seen what is infix, we have seen what is postfix, we have seen what is a infix, right? Sorry, postfix, prefix, and infix. Now, if you want to convert from infix to postfix, okay, so let's assume this is a one expression that you have in an infix. Okay, the user have given you this input that, hey, you have written the program that, or you have written the calculator. Okay, and your calculator, the user is giving this input that, hey, calculator, solve this equation for me. Okay, so what you have to do, okay, and instead of a b, maybe there will be 5, there will be 2, and so on. Okay, but you will get this equation as input. So we have already learned that in these cases, what is problematic? The problem is that even though infix is actually easy for us human to read, write, calculate, it's not easy for computers. So what do? We take help from postfix or prefix. So before we can take help from postfix to prefix, what we need to do, we just first need to understand how you can convert from infix to postfix or so on. So let's see here. First of all, as you can see, if we two things, that whenever I converted this infix to postfix, the first thing, operand order does not change. What does this mean? If you look closely here, the first one was plus, here the first one is plus, the second one was multiplication, here the second one is multiplication. Then you see here it changed. Okay, so what does sorry, I was talking about the operators. Okay, so the operators are in the order of evaluation. So basically that here the plus one would be used first, then here this plus will be used first. So this, if you look at this one closely, these are actually sequential order. Just one change. If you look at this subtraction, this is actually in the last. Now, why this operator is in the last? Because as you can see from this point, operators are in order of evaluation. Okay, so what does this mean? That means whenever you actually calculate this infix equation, okay, which one you will do first will come first here. So you'll evaluate plus first. That means you will apply this plus operation first. You will apply this multiplication operation after that. You will apply this plus operation first. Then you will apply this division operation, and finally you will apply the subtraction operation. Those of you who still didn't understand the point of this, let me explain one more time. So what does this line means? Operators are in order of evaluation. That means this is the infix and this is the postfix, right? So in the infix, okay, if it went normally, okay, so what you would do, you will first use plus, right? A plus B, you would do this calculation, then you will do this calculation inside the bracket. After finishing this part, you will try to finish this part first, that is D plus C, then divided by F, and after that you will go for the minus. The result of this area and the result of this part will be subtracted. So in the postfix, somehow they are also in the same order. So this is what does this mean. An operand order does not change. So if A was here, A is first, then B, then C, then D, then E, then F. So operand order does not change, and operators order change, but they change in the order of evaluation. Yes, Shakil?
স্যার আমি বাংলাতে কোশ্চেনটা করতে যাচ্ছি।
Okay, let me pause the. Okay, so very good question, Shakil. Let me give you the answer. So whenever we are actually using this postfix, so if there are two operations, A plus B, okay, what we do, we write AB plus, okay. But if that means we write the operands, okay, AB, okay, and then we write the operation. Now, what if there is actually a complicated expression? Like let's just take this one, AB into C. Okay, let's just take a simple, that means just this one. Okay, so let me just put brackets here. So we will first calculate this one, okay, A plus B, and then we'll multiply with C, right? So in this case, what happens, the rule is actually again the same, that we will put the operands first and the sign later. So what happens here, that if I actually apply in this part A plus B, what happens, it becomes AB plus. So this one actually becomes one whole, this one actually becomes one whole operand. So this is now AB plus is a single operand. So you can assume that AB plus equals to X. So, and then we have multiplication C. So now basically what we do, we write the operand first, and then we write the operator. So let me just draw and explain. So first what we did, we first, when it was A plus B, what we did, we have written operand, that is A and B, and then we have written the operation. So again, in the same case, when it was the equation was a little bit difficult, we wrote the A plus B first and then the plus, right? Now what happened, when we use this one actually became one operand. So this is as a whole is one operand, and this is a operation, and this is another operand. So again, what we will do, we will first write the operand as a whole. Okay, this is just like a package, okay, just like a boxed in. So this one will come first, then this C will come, okay, and then this operation will come. So Shakil, are you clear about the confusion?
Yes sir, I am clear sir, but I want to know another thing. আমি যদি স্যার এখানে A plus A B আমি সবগুলো অপারেট,
the program has to follow a simple set of rules. Okay, the rules is straightforward. Program cannot actually change the rule in the Polish notation. The program rule is straightforward. Okay, that's the how they have applied the program, and we are actually if you change it, okay, there's a high probability your equation will not work. And I think in you might test it on your own. Okay, so let's go and see some applications so you can test on your own. Yes,
sir, I want to ask a question, sir.
Yes, please.
Sir, I want to ask a question, sir.
Yeah, sure, go ahead.
Sir,
so this is just an idea that how we can actually what happens when you convert, but problem is how can we convert? So that is what we will learn today, that how can we convert from infix to postfix. So let's go there. So from whenever you're trying to convert from infix to postfix, again we use stack, okay, And in the stack, we have basically 3 rules. Okay, so what do we do? Okay, in this one, we use 3 basic rules, that if it is an operand, we append to as output. If it's a first bracket, that is opening bracket, we push into the stack. And if it's a closing bracket, we pop and append until we get a first bracket. I know this sounds a little bit complicated, but let's just go to an example and you'll see this is actually very simple. So the example is here, this one. So this is an infix. Okay, so what we'll try to do, we will try to convert this infix to what? A postfix. So again, let's go back to the rules. What are the rules? If it's an operand, we will append to output. If it's a first bracket, we'll push into the stack. If it's a closing bracket, we'll pop and keep actually popping until we reach a first bracket. Okay, let's go back, see what happens. So first, what we get a first bracket. So what is the rules? If you get a first bracket, push it to the stack. So you see that is pushed into the stack. Again, we get a first bracket. What is the rule? Push. First bracket means push into the stack. Sorry, I should say opening bracket, not first bracket, my bad. Opening bracket means push into the stack. So you see it's pushed into the stack. And again, we have another opening bracket, so pushed into the stack. Now, you have the first operand, A. So whenever you have an operand, it will directly go to the output. So the A directly goes to the output. Then we have another sign that is plus. So it will go to the stack. So operator again goes to the stack. Operand, okay, what does this operand will go? It will go to output B. And now we face the third rule, that we have a closing bracket. Now let's go back again one more time to see the rule. So what is the rule? If this is the closing bracket, we have to pop and append till we get a opening bracket. So let's go back here. So this is the currently what we have, and we have reached a closing bracket. So what we will do, we'll keep pop. Okay, so we will keep taking items from the stack until we reach opening bracket. Now, many of you, what you do, make a mistake that you assume that this is actually the front of the linked list stack, because in this way it actually looks very confusing. So which one is actually the head or the top of the stack? Remember, if you get confused by this view, you can use this type of stack. Okay, so here we have pushed 3 first brackets, right, and pushed plus. Now you can tell me which one is like the top of the stack. Obviously the plus sign, right? This is actually very clear. So what we will do, we'll keep using the pop function until we reach a first opening bracket. So here, whenever we actually keep use the pop function, the plus actually comes to the output. Okay, and then we actually reach a first bracket. You see, just after the plus sign, we have a first opening bracket. That's why we stop. Okay, and then we stopped, and then again we start from here. So again we have a multiplication sign. So this multiplication sign will go into the stack. Then we have again our opening bracket, so it will go into the stack. Then we have a C that will go into the output. We have a minus that will go into the stack. So everything is normal until you reach a closing bracket. If you get a sign, push it to the stack. If you get a operand AB, you will push it to the output section. Then E is again pushed into the output section. Then when we actually get a closing bracket, again we have to, what we have to do, we have to pop until we reach a opening bracket. So here, as we can see, that after the minus sign, there is already an opening bracket. So we don't have to do much. We just can write minus, and then we can go back to our stack again. So when you reach your stack, you will see there is another closing bracket. Okay, so that means currently this is my stack, and then there is another closing bracket. So what we will do, we'll again use the pop function until we reach a first bracket. Luckily, just after this multiplication, there is opening bracket. So we will stop there. So we'll just pop the multiplication and then we stop. And then we'll go back to our equation. So there's a division sign. Again, the division will be pushed into the stack. There's opening bracket, goes to the stack. There is a F operand, goes to the output. There's a plus sign, goes to the stack. There's a G that goes to the output. And then there is a closing bracket. Again, there's a closing bracket, so it will actually pop until it reaches a first bracket. So just pop, after popping plus sign, it will reach here After popping the plus sign, it will actually reach our opening bracket, and then there is again another closing bracket. So after using the pop function, it will get this division, and then it will be empty. So our steps are done. So what we actually did step by step, just by using 3 simple rules, we have converted our infix to postfix. Now you might ask that why we're actually going through all this trouble. Okay, so one, I have already told you that it actually makes things easier for computer. Second one is that stack actually makes all this program much more easier. I will give you the link of the code. Okay, and if I get time, I will also discuss the code as well. Okay, so you will see in the code, to converting from infix to postfix, the stack code is actually very, very small, okay, compared to other methods we have. So this is the basic idea. Okay, now this is the concept one. Second part of this is that, let's assume here you can actually use a way like this, that this is actually taken from Wikipedia and you can see it from there. Okay, so the both of the concept is same. Okay, so whenever they actually this is one stack, this is another stack. Okay, so you can use any of this. I prefer this one personally. It's easy to keep track, but this one is actually easy to calculate. So it's up to you how you want to do it. If you want to this two is actually totally similar. Let me just explain a little bit so that you guys can give an understanding. So first we start with A. Okay, so as this is a character, we push it to the stack. You see A is in the stack. So this is, sorry, this is output, not stack, my bad. So as this is the operand, we actually send it to the output. So A is directly sent to the output. So these are all the outputs, and this is at the stack. So A stack is empty. Then we reach the plus sign. Okay, so when we reach the plus sign, what we do, we push it to the stack. So you see stack has a plus sign. Then we go for the next one, first bracket. So this is a bracket, opening bracket. So we push it to the stack. So it's simple. We are just, whenever we are getting a character, these are being sent to the output. If you are getting a sign, that is operator, we're sending it to the stack. Okay, so the same thing that we did is the same thing that is done here. The only difference is here it only takes one page. It's easy for you to keep track of. But in this one, okay, the one that I have just shown you step by step, will takes a lot of steps. Okay, I mean a lot of pages. It's hard to keep track. So it's totally up to you which one you use. The only target is that you have the right answer. Now we have seen how to convert from infix to postfix. Okay, now we will see how to convert from infix to prefix. That means it will come in front of it. Now this one is actually not that much important for our course, because we already have one that could be understood by our compiler or computer. That means if between the postfix and prefix, if you learn one of them, that is actually enough. Okay, and in future, if you get time, which I don't think we will, because the exam is 15th. Okay, so just in case, okay, the prefix is basically the opposite of what we did in the postfix. Okay, so anyway, so all the contents are in the slide, and you can find the table as well, and we'll see that basically what they did is same as the postfix, just a little bit the opposite order. Now here comes another one, that how we can convert from postfix to infix. Okay, this is almost similar to, like, you know, the topic you have learned, how to convert from binary to hexadecimal to decimal. Okay, what we learned this conversions, the number system. We know the decimal is enough for us, but we have seen that decimal is actually not enough for computer. It needs hexadecimal or binary or octal. So that's why you have learned different ways to transform it. Okay, it's the same happens here.